team at Smedley Middle School must decide on several fundraisers to pay entry fees for contests and other expenses. In August, the students decide to have a problem-a-thon. We used to do this in 5th grade. We would do a problem-a-thon for... Do we do it for St. Jude's? I don't remember. But you had to go get people, kind of like this. Each student will work as many problems as possible in 20 minutes. They will get sponsors to give donations based on how many problems they work correctly. Jenny gets pledges from her friends and parents totaling $2 per problem. Gennaro, I think is his name, gets pledges of $3 per problem. In the previous lesson, you determined the independent and dependent variables in the verbal description above. Write a sentence using is a function of that describes the relationship between the two variables. So, let's think about it. What are the two things that could change in this situation, in this scenario? What are the two variables we're looking at?
The money and problems.
The money earned and the problems worked. Money earned and problems worked. So, which one is independent? Which one is dependent? That's correct. It's one of those hints I told you. If we have money, think about it being the Y. Money is the Y 98% of the time. So the money that these people earn depends on how many problems they answer correctly. Money depends on problems. Right? The problems they work doesn't depend on how much money they earn. That doesn't even make sense. But the money earned depends on the problems they work. So we would say that money earned is a function of sounds good. Function of problems solved, problems worked. I'm just going to be different than both of you guys, just because I can. Problems correct. All those are fine. All right. None of our answers are more right than the other. Those are all just money is a function of problems. Questions there? 2, complete the following table to show how much money Jenny and Gennaro earned for each number of problems they work correctly. Be sure to understand the labels for each problem. So if they work 5 problems correctly, how did you get that? So she got 5 problems correct times $2 per problem. That's what the process column means. You're doing 5 times 2, and that gives us 10.
So for the process part,
That's just where you're showing what you're actually doing. What math-wise are you doing? That's what goes in the process column. What about for Gennaro? 5 problems correct times $3 per problem means Gennaro is making 15. All right? I want you to work through that, follow the same process, and try to complete that table. What do we get on the next one? It would be 10 times 2, which is 20. And this should be 10 times 3, which is 30. Next would be 15 times 2, which is 30, or 15 times 3, which is 45. The next one would be 20 times 2, which is 40, or
You might need to change it to the yellow. You can't see the yellow.
yeah, you can on mine. 20 times 3, which is 60. Next is 50 times 2, which is 100, or 50 times 3, which is 150. Lastly, we have 100 times 2, which is 200, or 100 times 3, which is 300. Now, what if Jenny worked n problems?
What?
The last one.
N times 2.
Thank you. N times 2. What is n times 2?
Any number times
2n.
Oh.
2n. We normally like to put the number in front, right? Our coefficient of our variable. Have you heard that word before?
Yeah.
Coefficient. Good talk. Okay. And then for the next one, that would be n times 3, which would give 3n. 3n. It tells me here, write a function rule, or write a rule for a function, g sub 1, that gives the money earned by Jenny when the number of problems solved is n. Use function notation. I told you this was going to go well. Look at y'all. Look at the faces. Look at everybody. Let's break it down. Let's break it down. What's a function rule?
Like the way it's set up.
It's the math that you do every time is a function rule. So like in the math above, we were doing 2 times the number of problems worked. Right? 2 times 5, 2 times 10, 2 times 50, 2 times 100. That's our function rule. And then it also says function notation. That's what you guys were talking about. Function notation is f of x that we were writing before. So what would my function notation look like? It's going to be g sub 1. That just means a little 1. So g subscript 1 of n. And so this is the y value. All right, that's all this is. The y value is money earned. So the money that Jenny earns for working in problems is how much?
You multiply the problems by 2.
That's correct. The number of problems correct by 2. So that would be Jenny's function rule. G sub 1 of n equals 2n. Questions? Anyone? For real? Are y'all kidding? Everybody's got that just like that? You're a different breed. You're unbelievable. That's great. What's the next one then?
G sub n equals 3n.
Of n equals 3n.
Perfect. This is for Gennaro's money earned. Good. Did you? That's good. I mean, you're supposed to have done it before, but it still doesn't normally stick. I've taught people a lot. They still can't do this stuff. So this is a win. This is going great. 5. What does G sub 1 of 30 represent in the situation?
30 problems done by Jenny? Or...
That's correct. So that's not exactly correct. You're close. You're close. Jenny did work 30 problems, but what does G sub 1 of 30 represent?
That would be,
It's the money earned, right? Because that's your Y. So what does that represent? It's the money earned by Jenny for working 30 problems. Everybody follow that?
Yes, sir.
Because it's the whole function, g sub 1 of 30. So that's the y value when x is 30. Or when n is 30 in this case. And then the second part of that question, what is this value?
90?
No, it'd be 60. It'd be 60 because.
So which one are we looking at? We're looking at Jenny's.
Yeah, I forgot.
Jenny makes $2 for every problem. So that value is $60. All right, now on the coordinate plane, sketch a graph of these functions, labeling the axes. So I'm going to let you guys try this on your own without me doing it first. You're going to draw both of these functions on the coordinate plane. Let me give you a hint before you do too much. They are not lines.
I have no idea.
They're not lines. So, what did we say our x's represented? What's our independent variable?
The problem was.
So the x's, that's why I would always start with labeling. X is problems worked. What's my y value?
Money earned.
Money earned. So we could start with Jenny. So what does each one of these lines represent? The x's. Like what's this value here? 10 and then 20, 30, 40. So if Jenny worked 10 problems, how much money did she make?
$20.
So I would go to 10, 20, and plot a point. What if Jenny worked 0 problems?
No money earned.
No money earned, so it would be 0 here. What if she worked 20 problems?
That's 40.
What if she worked 30?
60.
What if she worked 40?
80.
We following?
Yes, sir.
So the points, they look like they are in a straight line, but I said it wasn't linear. So why would I say it wasn't a line?
Because there's also the values. She can't work anything in those problems.
Okay, that could be one. That could be one way to look at it. That's not what I was thinking, but that is also true. So we're not going to probably go right forever because she's timed. So she's not going to get to 8 million problems worked. Right? That's going to be too far to the right. But think along those same ideas. There's another reason why it's not a line. Because with your answer, it could be a line segment that stops at the point.
Would it just not continue like this? Like when the time stopped, would the line just like stay straight?
She can't do 2.5 problems.
That's it. That's what I was looking at. If I connect points, because these are lines, I'm saying that every point that exists between these points is also an answer. So if you think about it, let's narrow in right here on this little section between 0 and 10. What could happen between 0 and 10? How many problems could she work? Between 0 and 10. Problems worked. She could have worked how many problems correctly? That's between 0 and 10. She could have worked 10 and earned 20. What's another amount she could work that's between 0 and 10? She could work 5, 1, 2. That's what I'm looking at. She could have worked 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Do we follow? So what would happen if she worked 1 problem correct? She would earn $2. And if she worked 2, she would make 4. And for 3, she would make 6. And for 4, she would make 8. And for 5, she would make 10. Give me just a second. That's 1, 2, 3, 4. And so right there's my point for 5, 10. And for 6, you would make 12. And 7, 14. And 8, 16. And 9, 18. I'll put that dot as a different color because it's blending in. And 10, 20. So, now why can I not connect those points? Because what's between working 2 problems correct and 3 problems correct? Can she work 2.5 problems correctly?
No.
No, not to get money. So, that's why I said it wasn't aligned. That's why you can't connect them. So this is leading us to a different idea we're going to be looking at later. There are 2 different kinds of x values, 2 different kinds of functions. So think about these as like vocabulary words. There are continuous functions and there are discrete functions. Continuous means that I've got all these x's and all the x's between these x's also count. That's when we connect the line, when it's continuous. So if you think about like time. Is time continuous? Like if I looked at 1 second and 2 seconds, can there be 1.5 seconds? Can there be 1.25 seconds? Could there be 1.1 second? 1.03 seconds? Every amount of time between those x's also exists. But how here, that doesn't exist. That's what makes this discrete. I can't connect all the dots, but continuous you can. Follow, maybe. You don't have to know that yet. That's just where we're headed, where we're going.